Computer. So yeah, cool. So welcome everyone. This is Siddharth Mahabal here. I am part of the enablement team, and I also run customer experience here at Acceldata. Today's session that we are going to hear from our SME here in the solutions team, Devendra Rathod, and the session is around best practices and automation for the data plane. Before we get on to the session, I'd like to pass it to Devendra, and then I'll also introduce myself in the later slide, and then we can get kick-started with the session. Over to you, Devendra. You can introduce yourself and then hand it over to me before I hand it over to you again. Thank you.
Thank you. Hey everyone, I am Devendra and I am working as a subject matter expert with Acceldata. It's been almost a year and I'm most on working with ad hoc. Acceldata data observability platform. And if I talk about my previous experience, I have been working with this cloud, DevOps, and support kind of roles almost for 10 years. And here I'm providing up my expertise with ad hoc platform. So today I'm going to present best practices automation for the data plane. And I'll hand over to Siddharth for the introduction. Then we can get started about the uh, automation of the data planes.
Absolutely. Thank you so much. So here I just wanted to do a quick insight into the enablement practice here at Acceldata. My name is Siddharth Mahabal. Like I said earlier, I lead enablement and customer experience, and I've just joined in early November. For any insights, queries into anything enablement and training, I'm the one you should be reaching out to. You can see my credentials at the bottom of the slide. And one thing that I wanted to quickly highlight before we get started is the two links that should be handy. We'll probably paste them in the chat later. Uh, we usually have everything directed, anything which is knowledge base, anything which is support and stuff like that on what we call the Acceldata network portal. And here you will also find the latest sessions that we have around Accel Edge, which is part of the series that we're running. And anything education, training, certification, we have it in Accel Academy. So that's a separate link in case you're interested. But any which ways, you have the network portal where you have a separate tab that you can click and move on to Acceldata Academy as far as you have the login details. Okay. So do reach out if you have anything and let us know in case of any suggestions, questions, and concerns. So with that, let me pass it on to Devendra, who will take over the session and enlighten us about Dataplane. Thank you, Devendra. Over to you.
Thank you, Siddharth, for introduction and explain about the all these things. Let me begin. Okay. Welcome and the objective. Thank you everyone for joining this session. So today what we are going to learn from this session is like Acceldata has a data plane. And so like how are you going to install the data plane? What are the best practices to installing the data plane and how you can automate the installing of the data plane. Before I go to automate and installation part, I'm going to bit introduction about like how does it work, what all components are there in the data plane. I'm going to explain all those things. This session is designed for the platform team or DevOps team or administrator team who are the responsible for deploying this Acceldata data plane. So main objective for the session is understand end-to-end process for installing the Acceldata data plane, learn the infrastructure provisioning approach, how you can automate using the Terraform. I'm explaining in the slides, but you can explore another tools as well. Like you can use Explore, Polomy, or any another infrastructure provisioning tool. Also, you can explore and you can do CI/CD automation as well. Apart from that, we will do compare between automatic installation and manual installation, how it works in both scenario, and in what case you are going to use automated installation and manual installation, and how you can do automate this as well. Apart from that, we are also going to talk about best practices about automated deployment, upgrade, manual deployment, and operations and maintaining about those things as well. Okay. So before we move forward, we will be going to talk about the Acceldata data plane overview. What actually data plane, how does it work, and what exactly it means. So in data plane is the execution layer basically, and it will be connect your infrastructure wherever you want to connect. Like suppose you have a database are running in your platform like a Lakehouse or Warehouse or S3 Snowflake Databricks. So this data plane is going to connect with your data and perform some operation about the operations like you can perform like operations like a crawling, profiling, or data quality checks. All those kind of operation you can perform, and the results and back will be connected. It will be sent back to the control plane. So if I talk about in simple term, what exactly the data plane is, think of the data plane as like a worker layer in Acceldata. So it lives in your environment, not in Acceldata environment or not in Acceldata cloud. So it will be hosted in your platform. It might be in your on-premise environment. It might be in your cloud environment. And you need to manage all those component and service. It's connect to whenever you want to perform any operation, it will connect your databases, warehouse, and data lakes, as I mentioned, and whatever it runs all heavy works and in that data plane only. So like scanning the data or crawling the data, quality check of the data, profiling, collecting metadata, all those operation will be performed in the data plane itself, and it process whatever needed and send results and insight back to the control plane. And as I mentioned, unlike the control plane, which is managed by completely Acceldata, and it provides orchestration UI or API, and you can do automate all those things from the control plane. So control plane is where you are scheduling everything, but at the end, it will be running on your data plane only. Okay, so this is the core responsibility of the data plane. What exactly you can do that in the data plane? Metadata discovery and crawling. So basically, let's suppose you have a Snowflake and you have you have connected with your data plane, like data source are there, Snowflake, and you connected with that data plane, and you want to do some kind of metadata discovery and crawling of that. So identify schema asset of your systems, of your database as well. Data profiling and validation. So basically, whatever data is there, you do profiling and validation. So it will collect all those metrics into the data plane. Let's suppose you want to apply some kind of rules and execution. You can schedule those rules. You can schedule you can run some jobs for the data quality rules. You can perform those things and policies. So let's suppose you want to perform null check in your data. So you can schedule some policies for that, and it will be running into your data plane only. It has an option for the Spark job, like you can run jobs. You have you have an option for selecting engines, like you can select a Spark engine or push down engines. You can select based on that. It will perform your operation and it will take back the results. Telemetry and monitoring. So it will basically provide you health of your metrics or pipelines and jobs running inside the Kubernetes. So whatever service are running inside the Kubernetes, all the health and monitoring will be health check will be provided back to the again control plane as well. And secure data movement, like again, like how does it connected between data plane and control plane? It's basically it's connected via secure tunnel way communication, which I'm going to explain in further slides how it will communicate between control plane to data plane as well. Okay, so how exactly this data plane fit into our architecture? in ad hoc architecture. When we say ad hoc, is both control plane and data plane, and where exactly it will fit the data plane. So as I mentioned, ad hoc has two components mainly. One is control plane and another one is data plane. Control plane is managed by Acceldata. It perform like all orchestrated kind of platform things like jobs, storing results, managing users, all kind of things you can perform into control plane side. It's a multi-tenant environment and centralized control. Basically, you can manage everything from the centralized platform. It's the control plane. Data plane is the where you deployed into your environment and you only going to manage this environment, and it runs the data connectivity process all this data in your environment, and it will connect your data source, and basically it's isolated, secure, and close to more your data source where exactly your data source is running. So this is the entire architecture of the control plane and data plane. So if I talk about how does it work is, let me walk you through about the architecture, how it will work here. So if you see here, there are two main components are there. If I talk about high level of the architecture, is one is control plane and another is data plane. So if I talk about in simple language, control plane is basically decide what to run on with what configuration. And if I talk about data plane, decide how and where the job actually need to run. So if I talk about separate of part of this here, so let's suppose a user trigger the jobs from the UI. So if you see here, a UI option is there from the user, from the UI, a user will trigger one of the jobs. It may be any kind of jobs, like if you are running a DQ jobs or anything, you can run trigger here. That request first reach out to catalog service, and if you see the catalog service, it will connect it will basically the JSON, it will basically in JSON payload, and it will collect more informations about that, like connectors of their versions, engine configuration, engine type, like what you selected, like a Spark, push down, standalone, all those things as well. uh, Based on that, it will validate your request. Once it will validate your request, and then it will forward your request to the data plane. So whenever the request forwarded from control plane to data plane, it will go to the slash API data plane, and it will go to the again it will go to the analysis service only. So as soon as your payload, whatever you have sent, it will go to analysis service, and that does not, the payload whatever you sent, it does not modify as well. So whatever you send as it is, it will be go to analysis service. So basically, in simply route your request from control plane to data plane, and from analysis service, it will route your engine. Basically, if you see here, there are multiple engines are there, like a standalone service, crawler, push down, and Spark. So whatever request is coming from the analysis service, it will route again a standalone service or crawler based on that what you have defined as well. Now the requests go to the dependency manager service. So dependency manager service is rely on that, like whatever request you send, basically it perform all the schedule sync, and it will perform all this consistent version. It will perform those operations as well. So if you can see here, there is a one more thing is artifact registry as well. So artifact registry is nothing but it's like Acceldata provide two artifact registry options. Like one is Nexus and another one is client artifact registry as well. So it will be basically all the API jobs and submissions will be stored there as well. So in short, if I explain about this entire architecture is control plane decide what to run, and data plane it decide to how to run basically. And it basically depends on the manager service, dependency manager service. Okay. Now, how this communication will happen from control plane to data plane. So there is a one service called in data plane, it will be called cloud bridge service. Basically, this will provide a secure communication between control plane to data plane without running inbound network access or without modifying in your customer infrastructure as well. So key benefit for this is encrypted and control job execution communications, zero inbound firewall rules, mutual TLS communications. So it require both from control plane side and data plane side authenticate each other, and it's signed a self-signed certificate as well. And whenever the request sent from data plane to control plane, it will validate before the connection is established. So how the execution flow will be there, like you register the data plane from the control plane UI. So in control plane UI, you have an option for the registering the data plane. Once you register that, if you go into the register tab, you will see that options, and you need to enter some details as well, like namespace, version, registry, the name of the data plane, all those things, options are there. And it runs on the Kubernetes. So whatever data plane you are going to deploy, that will be run on Kubernetes only. And apart from that, it has a multiple services as well. Like as I mentioned, like analysis service, standalone service, all those services are there. Whenever you perform the job execution, so again, it will perform data processing task, and it runs in your local source only. So whatever you perform, it will connect to your data source, and whatever results will be there, it will be sent back to your control plane for the UI and reporting and alerting as well. And UI visibility, easy to read the data from the UI, all those results and dashboards, you can filter out all those things as well in the control plane UI. Okay. Key components inside the data plane, like what all key components are present inside the data plane is analysis service, one service is there. So what exactly analysis service is? Analysis service is the core component, and it's responsible for your requests coming from the control plane basically. So this request is typically involve data crawling, profile or sample data extraction, or any kind of request is coming. And this service interact with another services as well in this stack, based on that it will task, and it act as a like execution engine of the job initiated from control plane. So whatever the service request is coming from the control plane, it will come to analysis service only. Then it will, based on the request, it will interact with another service as well in this cluster, in this multiple services as well. If I talk about analysis service, analysis SQL service, it's a dedicated handling for SQL push down execution. So whenever, like if you are running any job from the control plane and you are selecting the push down engine, in that time it will interact with analysis SQL service. So it's a basically it optimizes data operation and offloading processing large query to the database rather than bringing data into the Spark engine. So let's suppose yeah, in this what exactly happen is, if you are running query with a push down engine, and if you have a query has a lot of data, so in Spark engine, what exactly it will do in that case, it will all this query data downloaded in the Spark engine, and it will perform operation there. But instead of that, what exactly push down it will do, it will perform in the system only. It will directly connect your source system, and it will perform the operation. So it provide a very improved performance, faster as compared to the Spark engine, and it is more efficient as compared to push down as well. One more service is analysis standalone service. Analysis standalone service is basically lightweight, using it's a very lightweight processor, and it use local Spark engines. It's include connection checks, basically when it's required, when you have a sampling data, different source. In that case, you are going to use this service. This is also part of your data plane service as well. Next service is API gateway. So API gateway is like a entry point for your request basically coming from the control plane. So as I mentioned, whatever request coming from the control plane, it will come to the control plane for API gateway, and it's a like entry point for that, like what it will authenticate your incoming request and then forward them to again analysis service as well. So it will authorize your request and process to the data plane as well. This we talk about tunnel client cloud bridge. So this is a network connection between data plane to the control plane. So this will make sure that establish a connection between the data plane to the control plane in a secure way communications between data plane to control plane. Now, next we are talking about Spark operator. So again, I mentioned we have a supported different engine as well. So whenever you are running any policy in your control plane, you have options for running policy, selecting the options for like this push down engine or Spark engine. So when you select the Spark engine, there is a Spark operator service is there. So application will be submitted as a Spark application, and Spark operator is responsible for your whatever the jobs you are going to run. Based on that, it will create a driver and executor, and it will perform all those operations, and it will send back the results there. You can Unicorn scheduler is basically a scheduler. It's manage your scheduling the jobs in your infrastructure. So whatever jobs or whatever Spark jobs are scheduled in Kubernetes, so it will be basically it will find which is the right node into the system, and it will schedule on that node, and it optimize the resource utilization, ensure that the Spark jobs schedule efficient way, and if edge, then it will prevent a bottleneck of the resource outage as well. So if there is a, on the specific node, there is a resource outage is there. So it won't schedule on that specific node. So it is pretty smart. It will detect all those things before scheduling, and then it will analyze all those things, and then it will schedule your job to a specific node. Spark history server is basically you can say that it maintain execution history of Spark jobs. It's like a monitoring, you can say. It will allow a user to review the execution history, details job, troubleshoot failed jobs, all those things you can do in Spark history server. So if any job is failed and you want to know reason or troubleshoot that, you can check all this execution history from the Spark history server if this feature is enabled and if Spark history server is up and running in your service. Okay. Next service is touch monitor service. Basically, touch monitor service is track cadence jobs. Basically, cadence job is basically it will running on every hour in your systems, and it will basically include the data freshness metrics. It will collect the volume bytes, new record count, all those things. It will retrieve those information into the system, and it will retrieve from both the JDBC and non-JDBC data source as well. So all the freshness things happening via touch monitor service as well. Redis is a use high performance caching layer in the data plane. For example, like if you have sample data is generated by analysis service, and it results is stored temporarily in the Redis service, and then it will load response. So if you have multiple requests, in that case, it will be utilized. So it just stored for some kind of temporary purpose, and then it will load from your. So like it will improve your response time. Like if you have multiple requests are coming all together, so it is a queue, basically, you can say. So requests will be served one by one, and it will improve your response time as well. Kubernetes dashboard is some things it will give you your infrastructure overview about the cluster details as well. Like all those things, what I'm talking about, those are a service are running and managed by infra team. And if you have a data team and who are taking care of data perspective, like from the control plane operation data analytics, and you don't have visibility about this, in backend, where exactly running, how it's running. So in it's integrated with ad hoc itself. So in the UI, control plane UI itself, you can check how many pods are running inside your cluster, logs of the pods, resource usage, pod, cluster, all those things you can check in the data plane as well. Okay. Now we are coming back. I just explained about ad hoc and control plane and data plane and how like what all services are there in data plane. So I give you a big picture about the components. Now we are more talking about the data plane deployment and management of the data plane as well. So, like, how are you going to deploy that data plane, and what all options are there, and how you are going to install the data plane? So, if you want to install the data plane in ad hoc, so first you need to go to the an ad hoc control plane UI. There is an option for the registering data plane. If you click on the registering data plane, you have options for the configuring data plane settings. So, based on that form field. Like you need to enter the name of the data plane, you need to give the namespace where exactly run, and then you need to enter the version, which version you want to deploy. And based on that all filled form filled, it will give you a YAML settings as well. And then you will have options for that automatic deployment or manual deployment as well. Once the data plane install, like you can perform your operations like crawling or profile or Spark configs, all those things you can play with that. So this will be a very high level overview of how you can install your data plane in your cluster. So now we are talking about provisioning from the automations. So there is a one way, like as I mentioned, like when you are going to create a data plane, here the prerequisites is there, like where exactly run this. And as I mentioned, data plane is required a Kubernetes cluster, and where exactly your Kubernetes cluster will run. It might be run on your EKS. EKS is a managed service from AWS. It might be run on Azure. In Azure, there is a managed service of Kubernetes AKS, Azure Kubernetes Service. Similar way, Google have managed service. And you can run your own cluster on premises or OpenShift cluster wherever you want to run. So you need to create a first infrastructure for the running the data plane. So if I talk about here in the next slide. So, like, how are you going to create that infrastructure? It might there is always options. You always create a manual way, but if you want to do automate, you can create that all those infrastructure requirement. You can create using the Terraform. This is a one just option. I choose Terraform, but there are a lot of options are available. Infrastructure provisioning. If I talk example of EKS. In EKS, in AWS Cloud, EKS, always you can use Terraform, but in AWS, there is another service, inbuilt service as well available is you can utilize those as well. Apart from that, in Azure, as ARM templates are there, you can use those as well. And you can use a similar service as well, Terraform or Polomy as well, you can use for creating your infrastructure. So how you're going to create an infrastructure is like maintain that whatever code you are going to write. Let's suppose you are creating ES cluster. So whatever Terraform modules are there, maintain some in a place where version control will be enabled, like Git, Bitbucket, or GitLab. Install those all your code there, and then integrate those code to the CI/CD pipelines. So it might be integrated via GitLab CI pipeline or GitHub Action, or you can utilize Jenkins as open source tools for CI/CD platform. So like what all Terraform will provision, like you can create a EKS cluster, you can create a node group, auto scaling group, networking, like design your VPC. If it's already existing VPC, then use the Terraform data modules. So use existing resource as well, like VPC, subnet, security groups, IAM roles, storage, all those things required. Once your EKS cluster is ready, then you come back to an ad hoc UI and select the data plane installation, and your infrastructure is ready. Select that cluster and it will deploy your cluster. It will deploy your data plane in there. So key benefit for this is like zero manual step. Like once you do automate, you don't need to follow each time manual steps. And if you do follow manual steps, it might be you miss something which you don't know. And let's suppose you have multiple data plans. In that, it will be challenging as well. Like managing multiple data plan via manual steps. Again, it will be a big kind of point as well, and it will be challenging when you manage multiple data plans. Second option is consistent. Like what you created, let's suppose you created one data plane, now you want to create another data plane. So both are consistent, and most of the config should be remain same. You're not gonna miss those things as well. And if you are following the environment practice, the UAT, pre-prod and prod environment practice, in that case, it will be helpful. Like if you want to move from the UAT to prod, it would be easy for you while upgrade or manage all those things. It will be very easy. Again, it will be faster. Again, it will when you have repetitive task. If you do automate, it would be easy for you to manage as there. And auditable as well. So let's suppose in the manual steps, you created an infrastructure. You don't have an audit. Like you, if you want to track who did what changes, there is no way you can track those changes. But if you provisioning from the infrastructure as a code and version control, then you can track the changes, who did what changes and what by what time it did changes. So if something is failed, you can easily find out problem, and easily you can figure out where exactly the problem and by what changes it's a created problem as well. So it would be very easy to track the changes as well. So I just give very basic example how you can manage your Terraform repo structure if you have multiple environment. So I just call like Terraform Dataplane. So Terraform Dataplane, and inside that you can call a module. Module will be reusable. So based on that, like you don't need to create each and every time separate module. So let's suppose you have three environment, dev, UAT, prod, or pre-prod as well, four environment. In that case, you can utilize a module as a central repository, and you don't need to modify this module code each and every time. You just what based on the dev environment. Like dev environment is lower environment and prod is higher environment. So in the lower environment, you might be have a small config size. Might be your Kubernetes cluster size is small, the number of node size is small. So you can pass that config inside the dev environment. So inside the dev environment, you can create a TF-vars backend, all those things, variables, files, and everything here inside the dev. And you can call the main modules. This will be the main module. And here you can define your VPC, EKS, and IAM. So let's suppose I want to create EKS. So in this variable, I define the size and everything. And then I'll call the module which is present in that module. It will be present EKS. So it will call this EKS inside the present, and it will create a EKS for you. And same thing, in UAT, I want different configuration. So whatever the configuration different I want, I can put into UAT folder, and then I call the module perspective. So I don't need to change each and every time the module folder as well. So this is the reusable modules. Each and every time you don't need to rewrite the module from the scratch for your environment. Just write one times your module and design this way. And you once you're done this one, you just need to utilize these things. Um, Once you design this code this way, and again, how are you going to maintain this one? Like, is there any user need to be maintained? Let's suppose I created this structure and everything, but you have multiple member of team. Who will responsible for these things? Like, I am only person who's the responsible for maintaining these things. No, you can do automate this thing as well. Like you can push these things to the GitHub and configure the CI/CD pipeline automation way. So as soon as if you want to make any code changes, you can just go to the GitHub and make your changes and push that changes into GitHub. Someone will review your PR and approve your PR and merge into the code. As soon as the code will be merged, again the pipeline will come into the action. It will perform all the tasks. Like it will check what exactly the infrastructure is present currently. What you are going to change. It will compare, and then it will going to apply those changes into your Terraform. It will create infrastructure for you. So no need to dependent on the single person in that case, and it will be automated entire from what changes you want to do. And again, I mentioned like it will be consistent. It will be like if you have repeated environment, multiple environment, in that case, it will be helpful for you. Across the environment, you have no need to repeat each and every steps. You just need to do one time task, and then you can create a multiple environment, and you can maintain multiple environment as well. Okay. Now, whatever the prerequisites are there for installing Dataplane, we already talked about that EKS cluster and how are you going to manage that EKS cluster. We talk about that using Terraform you can manage. So now you have each and everything is ready, underline host. Now you need to install the Dataplane. So how are you going to install the Dataplane and what are the steps you need to follow? So again, it will be the same. You need to go, you can manage these things from the control plane UI. In control plane UI, you have options for installing data plane and registering the data plane. And when you select the option for that, you just need to fill the form. And once you fill the form, there you will see two options. One is install via automated or install via manual way. So if you select the automatic way, in that case, all the you no need to worry about things. You just need to download one curl command and you need to run. And it in backend it will run Helm wrapper for you, and it will create a entire stack. What we talked about earlier, like all the services, like which I was explaining about earlier, like a standalone service or a analysis service or Redis. Spark operator, all those services will be created. You just need to run one command and it will create for you. It's a good practice if you have doing some kind of POC environment or low experience with Helm or Kubernetes, and if you want to do faster onboarding, and in that case you can utilize these options. And if you are coming with a enterprise background and you want to track each and every step, then I'll suggest another options. It's a manual installation. This is what we recommended if you have an um, enterprise customer. So in that case, how we follow another components, like any component, if we installing into the into Kubernetes cluster, similar way we have a Helm chart for the Acceldata as well, data plane as well. So in this case, you just need to download the chart from the ad hoc UI. You can easily download that chart version, and based on the version, we'll keep upgrade the chart versions based on the ad hoc versions. Let's suppose ad hoc version is running 4.9, and ad hoc has released a new version of the 4.10. And how you going to upgrade? So that Helm chart will be available for you. So you can just download that new version, and you can see the differences between 4.9 version to 4.9, and you can, based on that, you can select the versions and select the components what need to be upgraded as well. So this is basically full control to you, or you can define each and every steps as well, like resource allocation, version upgrade, custom configuration you can do in your code as well. So this code will be stored into your system in your GitHub repo. Like you, if you are maintaining into source code control tool, maybe Git or GitHub or GitLab or Bitbucket. So you store this code into your system. Then you can automate this via, there are multiple tools again, but you can decide like Argo CD or Flux or Jenkins. But based on the trending on the market, Argo CD and Flux is the more popular when you are going to do automate deployment for the Kubernetes. So integrate with Argo CD and Flux for the automatic deployment. So it will be fully automated deployment. As soon as the new version is released, you just need to upgrade the version into your code. You just need to update the values file and chart version, and it will be fully automated deployment. Version will be upgraded in your environment. And as I mentioned, it's ideal for enterprise environment, multiple clusters, multiple environments. It's good, and long-term operational stability. It's trackable, auditable as well. Who did what changes, you can easily track in this scenario as well. So these two options are available at this moment for the data plane installation from the ad hoc control plane UI. Okay. Choosing the right installation approach, again, automatic installation, it's the best, simplest, fast, very speed. Like if you don't have any background about Kubernetes, Helm, all those things, don't have expertise on these things, go for automatic installations. But you are a big enterprise customer and you are going to manage multiple clusters, multiple data planes, and all in those kind of scenarios, we will suggest you go with manual installation with the help of GitOps terminology, and it will give you for the automation, governance as well, and change tracking as well. Easily you can change the track as well. Now, if we talk about the scalability and performance about the Dataplane, so as I mentioned, Acceldata Dataplane, it will completely on Kubernetes native tool. It will run into the Kubernetes cluster, and as I mentioned, explain about the services, analysis service, SQL service, API gateway, all the services are there. Now, how are you going to scale this operation based on the workload and all those things? So one of easiest ways configure HPA, horizontal part scaling, for the dynamic scaling. So whatever service you have configured, by default it will come by one service. That means one replica of each pod most of the time. So let's suppose you have a very high load of the number of policy execution, all those things. So in that case, what you can do is install metric server into your Kubernetes cluster. Metric server, what exactly do? It will fetch your Kubernetes service resource utilizations of your service. It will expose CPU and memory metrics. It will expose a number of metrics, but in generic, I'm talking about CPU and memory. It will expose. So what exactly HPA will do, configure the HPA, and HPA will look about those service export, like whatever you have defined analysis service limit and request for your analysis service. It will check that based on the request, what you have defined in the HPA configuration. Let's suppose you are defined in the analysis service, like if my CPU goes to the more than 75%, so if analysis service CPU goes more than 75%, in that case, it will scale the number of replica of analysis service. So it will handle your number of requests. It's coming from the control plane. Like if you are scheduling multiple concurrent jobs or policies, so it will be able to handle as well. So similar way, you can configure HPA for the analysis service, analysis SQL, API gateway. So based on the workload, it will scale your number of replica. Again, it's not always scale. It will also scale down as well based on the demand. Like sometimes you are scheduling a policy on frequent windows, like a specific window. Morning you are scheduling number of policy very high, but evening it might be very low. So it will scale your replica down as well. So it will do both, scale up and scale down as well. Recommendation steps setup is always configure HPA, enable for the core services if you are using. Another operation, another way is Spark workload. So Spark workload is always come with all granular functionality for scaling up and scaling down. Resource definition are also available in the UI. So when you are selecting scheduling a policy with selecting option for Spark engine, you have an option for that what kind of configuration you need to run into your underlying host. If you are running a policy with heavy data, maybe millions of records, and it take 30 minutes of the time. So you can define the resource limit request high. Based on that, it will create a Spark operator will create a driver and execute report based on the what you define, and it will perform your operation faster based on what resource you define, and it will the execution job will be finished as compared to faster as well. So this is the scalability and performance options available. It's a basically native supported tool into the Kubernetes. Security and compliance, when we are talking about ad hoc control plane and data plane, what are the key functionality or security perspective are there? So all data sets credentials. So in data plane, in ad hoc, you are connecting with data source. So let's suppose you have a Databricks or Snowflake. and you are entering to connecting to Snowflake, you are entering those credentials and everything. So all those credentials and are stored by the customer are secure, and it's available in there only. It's not we are not able to see those credentials. Acceldata does not have direct access to that credentials and all this data as well. Whatever data you are running into Acceldata platform, we don't have visibility on the data only. We just see the metrics of the data. Whatever the all this data and all those credentials will be stored into the Dataplane level only. Least privilege access model is basically whenever Dataplane services are running and required data objects, system metadata needed, execution following least privileges principles. So whenever you are scheduling any jobs, you can configure the least privileges permission as well. So configure the RBAC properly. So for the secret management or network policy or secret access management, configure the RBAC so it won't allow to run anything. A proper privilege will be defined on the cluster level. So whoever have an admin privilege, those people only can run those operations. Whoever have a read permission, those people can only read the data, not the read and write both operations as well. Auditability and changing tracking, like installation and configuration, can be fully managed by Git as well, and you can easily track, easily traceable as well. You can easily audit as well. Similar way, you can do audit option out there in control pen side as well. You can edit, you can track each and every changes, who did what changes. You can easily track those kind of changes as well. And enterprise compliance ready, it's designs like align enterprise security governance regulatory requirement like SOC, ISO, compliance framework. We have all those compliance already in our system as well. Maintenance and upgrade. Like now, you created a data plane, it's up and running. Now, like how are you going to upgrade and maintain that? Like if you are facing any issue, how are you going to handle those things as well? So if you deploy it via automatic upgrade, you just need, in those cases, you don't need to do much worry about those things in Acceldata UI only, in the data plan page itself. As soon as new version is available, it will show you upgrade options available. So as soon as you click on that new version available or upgrade or upgrade available, you click on that, it will ask you option which version you want to update, and based on that what version you select, it will be upgraded. It will just trigger the Helm wrapper in backend, and you don't need to worry about anything in backend. Helm wrapper will take care of all the services upgrade, like whatever the services are there underlying post, it will upgrade all the services, all these things. No manual Helm command you need to run, no configuration changes is required. You just need to few click from the ad hoc control pen UI, and your environment will be upgraded to newer version, and it will show in your control pen UI the new version is upgraded. Let's suppose you want to upgrade from 4.9 to 4.10. You just need to few click, and you will easily upgrade your environment to the new version. In the case of manual upgrade, in that case, you just need to follow some of the steps. Like you can always raise a support ticket if the new version is available. You can raise a support ticket for the Helm chart, for the new version Helm chart and images list. We will be able to share with those information with you in the case of manual upgrade. In manual upgrade, you need to follow like what are the previous version you have, where you are maintaining, and what we share the new version. You need to compare both, and you need to update those things. Like you need to update the chart versions if the service is upgraded. If I talk about analysis service version, if chart version is 1.0.0, and if it's remain the same in the new version, you don't need to do anything. But if it's changed in the new version, you need to upgrade the chart version in that as well. So it will be, you just need to raise a PR for that, and whatever the version difference are there, you need to make the changes. And then whatever tools you have integrated, it will automatically take care. Uh, like Argo CD or Flux, it will be taking care of that. As I mentioned again, it's very easy, and it's very trackable and auditable if you're following with manual process. It's controlled rollout across the VOD prod. You can maintain each and everything in the values file. You can so this values file, you can create a values file like something dev dash values .yaml. Similar way, UAT dash values .yaml and prod values .yml. So you can create a different config for each environment, and you can maintain those things. And yeah, this is the recommended way enterprise and customers and automate the environment. Yeah, I think this is the what I explained about the data plane and how you can automate, how you can install that. If you have any questions or anything, feel free to reach out to us. Maybe you can reach out to us on the via support ticket or via our community. All options are available. Thank you.
All right. Hey, Devendra, great session. Thank you so much. So maybe we'll give it a minute for any questions that might surface, and then we should be good to call it a day. Okay. So people on the session, any questions? Okay, I guess not. All right. So we'll call it at that. Absolutely great session. Looking forward to many more such sessions from yourself. And thank you for your time today, everyone. Bye.